Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. And today we are going to talk about temperature sensor. Well, what is a temperature sensor? A temperature sensor is a device that is used to measure the temperature across the environment or the object which is in contact with it and give a voltage difference across the terminals of the Arduino. The voltage difference here are also given in the form of analog signals because for the precise voltage it is not possible to take the signals in form of digital read. So we are taking the sensor reading in the form of analog signals. Okay, let's just talk about the temperature sensor here. We have connected here the temperature sensor named as LM35. LM35 is made by Texas Instruments and it is a transistor and which have a voltage linearity. It means you can say that whenever the voltage is applied across it will be showing you whenever a voltage is applied across it, and whenever a temperature is increased across the frame of the sensor, it will give a voltage difference across its middle terminal. And we have connected the middle terminal to analog read of Arduino, so it will give a temperature difference, and by having a small calculation you can get that there is a temperature difference within the atmosphere, or you can get the temperature of the environment. Okay, let's just see about the sensor. Here it's data sheet. I will be giving you the data sheet along with the PDF of the course. Okay, let's just see. Well, first of all, about the data sheet. A data sheet is a special type of document that is prepared for the with the a datasheet, a special type of document that gives the complete description of the electronic component, about its physical dimensions, its mechanical strength, stress, capabilities, and the maximum voltage or current it can take. All this data are given in a specific document, and that document is known as a datasheet. Here you can see that I have taken a datasheet from Texas Instruments about the LM35 sensor. It is a linear voltage device, and you can see that here are the physical dimensions of it, and we are taking about the LP package 3-pin TO92. This is the sensor that we are using here. Okay, these are its mechanical stress, strain capacities, its mechanical parameters, as well as its electrical parameters and working differences at other temperatures. You can see that here it has been giving operations at the pins and how to connect it. All the features are given in the datasheet. A datasheet is given by the company that had made the sensor. That gives the electronic engineer a complete knowledge about the sensor or the electronic component that he is using and how to use it or how to get the information out of it. So a datasheet reading is very important for the engineers to get a complete brief knowledge of the sensor or the electronic device. Okay, here its working temperature is minus 55 degrees Celsius to 150 degrees Celsius. Okay, let's just try to connect it to get a voltage reading. It's simply open the Arduino board, go to edit, go to examples, and go to analog read voltage for getting the voltage difference to you. We have connected it to analog pin A0, and wiring is as per the PPT. You can see that the first terminal is connected to 5 volts, the last terminal is connected to ground, and the middle terminal is connected to analog pin A0. Let's just see it in the Arduino voltage sketch. Upload it to the board. It's taking some time, and it's uploaded on the board. Okay, let's just see what is the voltage across it. At present it is 23 or 24. Okay, when I touch the sensor, the voltage changes continuously as I am touching, because my hands are warm. Whenever I touches the sensor, is going to increase its temperature. So as per the temperature linear coefficient, the value of the voltage across the terminal increases, so the analog read can read high temperatures across it. Okay, that is for the reading of the voltage. But how can we read the temperature? I have found a beautiful code here. Here you can see that it is exactly similar to analog read. Well, we are going to do it in the analog read also. Multiply the value. Okay, see here. This is the code that I have written. First of all, they are defining an integer. First of all, we are going to define an integer as VAL for value, in serial begin 9600 for the operations, analog read A0 because this is the pin we have connected for the sensor, and it is the equation down here. For the value MV, we are going to val divide by 1024 into 5000, and for CEL, we are going to divide MV by 10. Okay, for Celsius, and for Fahrenheit you can multiply the CEL into 9 divided by 5 and plus 42. Okay, just get the value for CEL here. I am going to upload it to the microcontroller, and we are giving a difference of 100 for better understanding or for quick operations. It's uploading. Wait for a second. It's uploaded successfully on the board. Now you can see the temperature, and whenever I touch it, the temperature changes. I am going to do a practical operation. I am going to put a matchstick around it. Wait for 1 second. You can see that the temperature is rising continuously. Please be careful while doing the operation, because it can fry the sensor if you have taken the matchstick for longer times. And for reading the Fahrenheit, let's just do a small change in the code where the CEL written, go there and write FARH for Fahrenheit, because the Fahrenheit here is the variable that shows the value for Fahrenheit as per the calculations of CEL, multiply by 9, divide by 5 plus 32. Okay, let's just upload it to the board. And okay, let's just see it. Here you can see that the temperature is okay, just a mistake, it's dot. I will be doing F for Fahrenheit, uploading it to the board. Okay, you can see that there is 89, 90 or 88 degree Fahrenheit, and whenever I touch it, the Fahrenheit values changes. Okay, but what we have to do in logical operation to it. I will be including logical operations from here for getting a brief information or brief technical knowledge of the program and how does the program work. Okay, go to here in void setup, write just a minute, write PINMODE, pin mode. We are going to collect an LED at pin number 2 and set it as output. We have set it at output. Terminate the line, come here, and I am going to select the value CEL for my understanding. That is good. Go down, write the if statement. If the CEL greater than say 32, the digital write LED will be high. Just a second. DIGITAL WRITE capital as per the syntax 2. And it's important to keep it also as an else statement, because without else you cannot turn off the LED. Give statement, write digital write 2, LOW. Okay, terminate the line and just upload it to the board. Wait for a second, I am going to connect an LED. Okay, here you can see that I have connected an LED to LED pin 5. Just see here. Okay, I have connected an LED to LED pin 2. Okay, we are going to upload the code and give it a name as TEMPERATURESENSOR. You can find the code at the beginning of the module for your practical purposes, or if you want to do an experiment. I have made a small error here. The P is capital and we want the P to be small. Okay, now upload it to the board. It's uploading. Just wait for a second. Okay, the upload has been successful. Okay, go here and let's just see. The temperature is 23 degrees Celsius. Whenever I am putting my hand on the sensor, the temperature keeps rising, and whenever it rises about 32, I am going to change this from 32 to 30 for quick operations. Okay, we have set it to 30. Again we are going to upload it, and the sketch is being uploaded. Now open the serial monitor once again, and I am putting my hand on the sensor so the temperature becomes high, and let's just make it about 29. Now let's just see it. Well, it is a better practice to set the values as per your precision, because it will help you in many sensor calibrations. I have calibrated it to 29 degrees Celsius. The word F is written here by syntax mistakes. I will be correcting it. There are two mistakes here. First of all, I am going to write C for this, and the light will be glowing for next 100 milliseconds to keep the program stable and give us a visible operation. I am uploading it. You can see here it's uploaded. Wait for a second. Open the serial monitor. Now connect your finger here. Just a minute. There was some loose wiring. I have corrected it. Now whenever I am going to put my fingers across the temperature sensor, the value of the temperature increases as follows. And whenever it goes about 29 degree, the light will glow, and when I put my hand back, the temperature will soon decrease and the light will turn off. Just wait for a second. It's going below 29 and it's flickering because it's oscillating between 28 and 29. Now you can see that the light has been turned off. Again, the light has been turned on for a few seconds. After getting below 29, it will turn off. Okay, you can see here. Again, well, this was the LM35 Texas Instrument sensor. This was LM35 temperature sensor made by Texas Instruments. And in this program, in this module, we have talked about the temperature sensor and what is the data sheet and how to read the data sheet for the temperature sensor. We have built a small program for reading the voltage across the temperature sensor, and as well as how to read the temperature across the temperature sensor, and had performed a logical operation. See once again. It's just going to blink, and whenever the temperature goes below 29 degree, it will turn off. Well, this was the operation performed by it to give you a simple logical understanding of the program. If you have any questions, you can ask me, or else thanks for watching.